All right, we're going to go through these problems one at a time on this review quiz. We're going to be looking very similar to your final quiz, so please pay attention to work shown or just how they're done. All right, so first one, kind of get a little start on it. We're trying to find what the uh, inverse sine of 1 is. Remember, that deals with the y value. Sine deals with y values on the unit circle. So we think, okay, where does the y value on the unit circle equal 1? Well, it's this angle here, 0, 1 at the top of the circle. That is an angle simply of pi over 2. So that's what this is equal to. And that's it. Don't have to go much further than that. On this one, we have inverse secant of 2 equals some angle theta. We're trying to find the angle. So we can rewrite this as secant of theta equals 2. But then we remember, secant is a reciprocal of cosine. So that means we can think of this as what angle for cosine is equal to 1/2. And that makes that a little easier because you think of the unit circle. And one way you can get partial credit on this quiz is to make sure you give me a unit circle or something, show me your way of thinking. So yeah, cosine, that's our x values on the unit circle. So here's a 1/2 value for x, which gets us this angle right here, which is pi over 3 or 60 degrees. So that's what, in other words, that's what secant, inverse secant of 2 is equal to. All right, moving on. Let's take a look at this guy. So this is where we're doing a kind of a compound situation here. So starting with cosine of pi over 4. So don't worry about the inverse secant just yet. Let's just focus on what cosine of pi over 4 is equal to. All right. So remember that cotangent of pi over 4, not cosine. Cotangent is x over y. Tangent is y over x. Cotangent, the reciprocal, x over y. So we think of pi over 4. That's a 45-degree angle, right? Which has x and y values. Well, they're the same. Pi square root of 2 over 2. So that means that this initial part in here is just going to be equal to 1. So this is really finding what is the inverse secant of 1. So we just said, and I'll restart this down here, so finding the inverse secant of 1, well, let's just think about it as an angle again, okay? So if we're trying to find what secant angle, or secant of what angle is equal to 1, again, we think about that as it's the same as the reciprocal of cosine. So I could say, that's the same as saying the cosine of theta equals the reciprocal of 1, which, that's 1 also. So where is cosine, which again, this is our x value on the unit circle. Where is it equal to 1? Right here. This is our only spot here. So that means that angle, all that stuff, is just equal to 0. 0 degrees or 0 radians, okay, is your final answer on that one. Moving on, let's do this one here. Started off some of it for you already. Cosine of pi over 6. So again, don't worry about the inverse sine just yet. Let's just work on cosine of 5 pi over 6. 5 pi over 6 is 150 degrees, or this angle I have shown down here. Here's the x and y values for that. So we're just dealing with cosine. Cosine, again, is the x value on the unit circle. So I'm looking for this value here. So the x value here is negative square root of 3 over 2. So that's the same as saying that this is inverse sine of negative square root of 3 over 2. So that, if you want to think about this as this is going to be some angle theta, you can say, well, sine of what angle theta is going to be equal to negative square root of 3 over 2. Remembering that sine deals with the y value on a unit circle. So I'm just going to draw a fresh unit circle over here. Now, it's not a very good one. Fresh unit circle there. When is the y value? So I have y value. Remember, this is positive y value, negative y value down here. So negative square root of 3 over 2 is around right here, a little bit less than 1. That's our long side of a 30, 60, 90. So if you think about what angle that's going to be, could be either one of those right there. So let's just, if I was just to take this first angle right here, this is 60 degrees here. This would be 60 degrees here. So it's either negative 60 degrees. We could say all this is equal to. So negative 60 degrees or a negative pi over 3. Or this one right here, that's going to be 240 degrees, or it's going to be 4 pi over 3, because it'd be another 60, another 60, another pi over 3, another pi over 3 to get to 6 pi over 3. So either one of those would be acceptable. I'd take either one as an answer. If I specified, make sure your answer is positive, then obviously you'd say the 4 pi over 3. Or technically, you could also say 5 pi over 3, because negative pi over 3 is the same as positive 5 pi over 3. They're the same angle. All right, so yeah, those are your answers right there in the middle. Let's take a look at this one. So we start with the cosine, inverse cosine of square root of 2 over 2. Well, it should be pretty obvious one. We're talking about a 45-degree angle with the square root of 2 over 2. And so really we're just saying, oh, what's the secant of pi over 4? So secant, well, that is the same as saying 1 over the cosine of pi over 4. Well, we just did the cosine of pi over 4. It was square root of 2 over 2. So this is really just the reciprocal of the square root of 2 over 2, which would be 2 over the square root of 2. Square root of 2 over 2, flip, obviously just turns into that. Now we don't want to leave it like that. We rewrite this, multiply both the top and the bottom by the square root of 2 over 2 to rationalize the denominator, which gets you to square root of 2 over 2. Those cancel, and your final answer is just square root of 2. Moving on to the last one of these types here. All right, so this is a little bit different because now we're not given a specific angle or type of number that gets us like 30, 60, 90, or 45-degree angle. So 2/5, not a common situation here. So what we do is we say, all right, sine, inverse sine, let's just say that's sine of some angle theta is going to equal 2/5. 2/5 I can think of as y over r if I want to put this on a unit circle, or it's just the SOH part of SOHCAHTOA, opposite over hypotenuse. So if I'm saying, oh, I've got some angle theta here, the opposite side is 2, the hypotenuse is 5. 2 over 5, opposite over hypotenuse. Okay, so if I want to work the rest of this thing out, I'm trying to find cotangent. So really my ultimate goal now is, whoops, not cosine, but is what is the cotangent of this angle theta right down here? That's what I'm really shooting for now. So to figure that out, I need to find, well, what is cotangent? First of all, it's the reciprocal of tangent. And if we finish the rest of this out, here, our SOHCAHTOA, it's the reciprocal of tangent, which is opposite of adjacent. So now we're looking for adjacent over opposite side. So we've got our opposite side over here so far. We just got to figure out what is our adjacent side. So all you need is a little bit of right triangle type stuff going on here. In other words, Pythagorean theorem. So let's call this just a squared plus 2 squared equals 5 squared if we want to work this out. So we'll have a squared equals 25 minus 4, which is going to get us a equal to the square root of 21. So that is our adjacent side down here. It's equal to the square root of 21. So when we finish this up here, let's get rid of, well, I'll leave it on there so if you need to see it later. This will be adjacent, which is square root of 21, over opposite, which is 2. And that's your answer. Moving on here. So now let's get into some law signs, law of cosines type stuff here. Law of sines, that's one you're going to have to memorize. Law of cosines, I'll let you have a note card or whatever for that. This particular problem, though, so it's not giving you an A, B, and C. It's K, H, and P, but it doesn't matter. So remember, opposite the angle P, that's side P. That's really important. You set it up that way. Opposite angle H, side H. Opposite angle K, side K. So don't forget to set those up properly and label those properly. So we don't know angle K, we don't know angle H, don't know side K either. So the one thing we can't do here is, I said find angle K first, but actually we don't want to do that. What we want to do, I can't find angle K because I don't know side K, but I do know side H, okay? One thing I know I have to use is P, because right now I know if I say, okay, if I wanted to find, let's say I want to find what angle H is. So I say, all right, sine of H over side H, this is law of sines, in case you didn't notice, that would be 20 for side H. And then the angle that I do know is sine of P, which is 110 degrees, and then side P is 32. So the one thing you have to do is use, if you're going to use law of sines, your angle and side, you have to have a pair that you know both of them together. So a little p, big P. In this case, you had to know them both. That leaves us with just one unknown here that I can solve for. So once I do that, I can rearrange this a little bit. I'll just show the initial steps to make sure we're good on this. Be sine H equals, and multiply both sides by 20. So 20 sine of 110 degrees over 32. And you can do it all in one step if you want. You could say, all right, that means angle H is going to be equal to the inverse sine of 20 sine of 110 degrees over 32. Okay, and basically just work that out. And okay, and this would be, sorry, I went away for a second there. So this guy here gets us for angle H, it's 36 degrees. All right, so once you know what angle H is, we go over here and write in here 36. That's pretty easy to find angle K. I'm not going to go into that. You just need to subtract 110 and 36 from 180. And so let's see, for angle K, it was 34 degrees. You know, how do you find your last missing side? The one side we don't have is little k. What's that equal to? Well, now that you have angle k, this isn't so hard to do. You just set up your law of sines. I start with my my little k up top, sine of k on the bottom of that, 34 degrees. And this is equal to, take your pick, really. I'll use the same thing we used before up here. 32 over sine of 110 degrees. And once you solve that for k, we should get 19. All right. All law of sines on that one, which makes you probably understand we're going to have to use some law of cosines at one certain point here. Now, on this next problem, we do have to use law of cosines or something other than law of sines on this one. Because notice, we're given only the sides at the beginning. So if we don't have any angles known at the beginning, we can't use law of sines. You have to have an angle to do that. But law of cosines, that is possible. And really, we can kind of take our pick here. What angle do we want to actually find first? So we might as well just go with A and work this out. So if we're doing this for angle A, so we start with side A squared equals B squared plus C squared minus 2BC, and it's cosine of angle A. Okay, so really this is just kind of a fill in the blank and solve this thing. Now remember, this is the super important part. This is our side A, this is our side C, this is our side B, all opposite the angles. And it's really important you name them correctly, or you will get some wrong answers in here. So this would be 18 squared equals 26 squared plus 24 squared minus 2 times 26 times 24 for B and C, cosine of A. So our goal here is to take all this stuff and get it to the other side. So you got to do this in steps, though. All right. Don't just start moving stuff around. We got to be careful about this because this is multiplied times the cosine of A. So we have to divide by that after we first take these guys over here, the 26 squared plus 24 squared. So I'm gonna skip a couple steps here. All right, so we get negative 928 equals negative 1248 after you do a little simplification. You divide both sides by this. Now, don't actually plug this into your calculator, what's here on the right or on the left side, because really our angle A, is just going to equal the inverse cosine of that negative 928 over negative 1248. Now, obviously, these are going to turn positive, so you could cancel those out. But just plug that into your calculator like that. Don't go rounding things off. You do that, we end up with issues. So if you do this one, let's see, number 8 for A, this should be about 42 degrees. So really all you got to do now is find one more angle. If you find one more angle than the third angle, well, you can just use the third angle theorem and subtract from 180 degrees. Uh, but the important thing here, I'm going to go ahead and write this in so I can visualize it now. Important thing now is I can use the law of sines. Notice I said you can't start with the law of sines, but now that I have an angle and I have an opposite side to that angle, I can figure out either angle C or angle B using the law of sines to figure that out. So I'll just set up the initial steps for that. I won't go through the whole thing. But if you say, okay, I want to find angle C. So let's just say sine of C over side C, which is 24, equals sine of A. That's the only angle I know so far, so I have to use A over side A. And you solve this, you rearrange it a little bit. You should end up with C is equal to the inverse sine of 24 sine 42 degrees over 18. And if you work all that out, you should get an angle C. Let's see, we get an angle C of 63 degrees once you do that. And of course, put these two together, subtract from 180, you'll get your angle B. I'll write it the proper way this time, measure of angle B, but it's okay if you just say big B there. And that would be 75 degrees. Okay, so no ambiguous case or anything like that on this particular one here. Let's go down here. Now this one did not give you a diagram this time. Draw your own, okay? But you can see we're dealing with the triangle ABC. Now I do know that my triangle A is for sure, or sorry, my angle A is 94 degrees. So don't just draw some random triangle like this and say, oh, let's call this angle A. Well, you might as well make it somewhat accurate. 94 degrees is a little bit bigger than 90 degrees. So we could say, all right, here's my angle A down here, 94 degrees. We'll label that. But where's the rest of it? Well, let's just draw it in like this. Let's say this is B, this is C. We know side B is 12, this is our little b, and side C is 13, so this is our little c. So we don't know what side A is, and we also don't know angles A and B either. So we have the situation here, though, where the only angle I have, A, I don't know the opposite side. So I can't use law of sines. You always have to have at least one angle and side paired up in order to use law of sines. So we're stuck with using law of cosines. So I do have a situation here though where I've got an angle A. Let's just write out one of these laws of cosine here. A squared equals b squared plus c squared minus 2bc cosine of A. Well, let's just look at this one because you'll have all these listed for yourself. Let's see what I know and what I don't know. So I know my side B, I know my side C, and I know my angle A. So I've got everything on the right-hand side, and I don't know what A squared is, so this is perfect. I'll just use this one and start plugging stuff in. A squared is equal to b squared plus c squared, c squared, minus 2 times b times c cosine of 94 degrees. So this is when these are a little bit easier for us. Don't have to do much rearranging. Just pretty much figure out the whole right-hand side and get your answer. So you put all that together and you should get something like 334.764, which when you work all that out, you get a final answer of 18.3 when you take the square root of both sides. So A is 18.3, so we can take that and say, oh, now we know this. I'm going to go ahead and draw that in there, 18.3. And the rest of it, we can use law of sines again. So I won't go through how to do that, but we basically need to figure out either angle A or angle B rather, or angle C. And once you have that, you can find the other angle pretty easily. In terms of what those answers are, again, I'll save time by not going through all that. The answers, let's see, so measure of angle B was going to be about 40.9 degrees, and the measure of angle C then is 45.1. So those would be your three missing bits and pieces. Let's take a look at this one right here. So we have a situation on this one. We're going to draw this in, but notice this is a SSA situation. Sometimes you won't know until you draw it out because you look at this and be like, okay, I've got a big angle here. A is 136 degrees, so something like this. This is our A. And then we look at this and say, okay, angle C, or side C, let's call it this side here. This side here is our C, and this is 35. And then over here, we could look at this and say, oh, I got some other side off here. I don't know what this angle is, but I know this is angle A here. So side A, opposite 33, like this. So this is a situation where we got to look at this and be like, okay, this is a special case for us here. Is it possible for us to have a triangle with this one? And we don't actually have to do very much with this, because if this is the angle here, I need this side here, A, to be longer than side C over here. Because if you think about this, if like this, the actual length of this would probably be more like this in comparison. 35 versus 33. So if you think about how this would rotate down here, well, it might hit over here someplace, but that angle then would not be 136 degrees for A. And in fact, this has to be long enough over here so that it would rotate down and hit somewhere in here, so we have a triangle that looks like this. But that is not the case. So really, we don't even have to do any work on this one. We can just draw it and realize, hey, this is way too short. We're never going to get ourselves a triangle here. It's always going to be a situation where we'll just never touch. I'll just rotate down through here and never hit this part of this side here. Remember, we don't know the length of this side. This would be let's see, this, if that's C, this would be, there'd be an angle C over here someplace, and this would be our angle B. We don't know what angle B is. We don't know what the length of side B is either. So this is just no solution. And really, we can just say not a triangle. Can't even be done. Not a triangle. That looks good. That's it. That's our answer for that one. This last one here, we have another SSA situation. We have two sides, and then we have an angle not between those two sides. So that's SSA. Um, so, yeah, that's funny. See, written out that way, written the other direction, but hey, it's true. So if we draw this, okay, we have some angle, 28-degree angle here. Call that angle A. Side A, well, that's the one opposite this, right? So side A over here, and this is our side C is 18. So I have some angle C over here someplace, but we don't know exactly where it's at because we don't know what this angle up here is either. This would be our angle B. We don't know that angle. So this thing could be pivoting through here in a couple different ways. So if we look at this, so let's get rid of this part here. We say, okay, side B is 12. Or sorry, side A is 12 over here. Well, we could say it could come down here and could hit once. Maybe it could come over here and hit again over here, where we have two possible triangles that could go on here. But we don't know until we figure out what this is right here. This is our H. So if you remember, we can figure that out with a little SOHCAHTOA. H would be the opposite of this angle, and the C is our hypotenuse here. So if sine of 28 degrees is equal to opposite H over hypotenuse, 18, I can figure out what H is just by doing sine of 28 times 18. So I'll do that really quick here. Sine of 28 degrees times 18 is about 8.45, or yeah, let's just keep it at 8.45. 8.5. That's this height here. Okay, so that means we will have a couple possible solutions here. We're going to have one where it hits over here, and then that angle will rotate through, and it could hit over here. So we could have two possible triangles. There could be one that looks like this big guy, all right, but then we have this smaller one that looks like this. Okay, so two possibilities. Sides A and C and angle A will stay the same regardless. Let's get this off of here. So let's take case one. I'm going to take the larger version of the triangle. So it's best to take this and like redraw it. So I'm just going to redraw this like this, and we'll say that we have A and B and C. We don't need H anymore. That was just to help us figure out what was going on here. This is side B. Don't know what that is. This is side C up here. That was 18. So we look at this and we know we have this angle, 28 degrees here. Well, we can use law of sines to figure this out then. Okay, because I do have an angle and its opposite side here. So the only thing I can look for first is that if I find the other known quantity, it's side C. So that means I should be looking for angle C, finding angle C first. So, and I'm going to call this, we'll call this case 1, or situation 1, large triangle. So that means sine of C over little c, 18, should be equal to sine of A, 28 degrees, over side A. So we could figure that out. For that situation there, for that large one, it would be, I'll just jump right to it because you could do the work pretty easily, I hope, on this one. Angle C in that case would be 44.8 degrees. 44.8 degrees. Okay, so now I can write that in here. Let's just use a different thing here. 44.8 degrees. That's what we've got. So that's our new known quantity. We only have one other missing side and one other missing angle. So the other missing angle, pretty easy to find. I'm not going to go into that. But for this situation, for that one, we would get B is equal to, it would be equal to 107.2 degrees. All right, so those are your two angles for situation 1. You just got to find side B, but pretty easy to use law of uh, sines again, because you now have the angle up here for B. You're trying to find side B, and really take your pick of any of the other two side angle combinations, since you know both the angles and the sides of both of them. So really quick then, B using law of sines again would be, in this case, 24.4. Right, so, but case number 2, a little bit different story, right? So case 2 would be this shorter one. So it would look like this. Let's draw that a little better. This one right here, this is the case we're talking about now. Okay, so all the stuff gets labeled the same. So this would be A, this would be B. Our angle C moves over here now, so it's a little bit different setup. This is still 28 degrees. This is still 18 over here for C. This is still 12 over here for A. Now this is a lot easier to work out because we've already discovered some things about this angle. Remember, back over here, this angle, 44.8 degrees. So if I draw that in right here, 44.8 degrees, well, this is an isosceles triangle here. The base angle theorem says that this is also 48 or 44.8 degrees. So we can figure out this angle right here, which is angle C down here, just by subtracting 44.8 from 180 degrees. That's the linear pair postulate, you might recall. So you get for that, what would it be, 135.2 for angle C. So 135.2 degrees for angle C, which means you can find angle B pretty easy. Again, just add up the 28 and the 135.2, subtract from 180, you get 16.8 degrees for angle B. How do you find side B down here? Well, the same way you would have found side B over here. You can use law of sines to figure that out. And so that little b on this one would have been 7.4. Okay, after using law of sines to figure that out. All right. That was probably the toughest one on any of these. The rest of these, I just give you a couple little area problems. So this first one, you are given 4 sides, A, B, and C. No angles, though. So this is the case where we get to use Heron's formula, which I will let you have this one also on a little note card, or I'll just supply it to you for this. But I want to make sure you guys can actually do these. So what is Heron's formula exactly? So Heron's formula, just right here. The area is equal to the square root of, well, all that. I'm not going to read it all off. You can see it. But it's important to know what S is. It's just half of all the angles summed up. So we've got to find S first in order to figure this out. So S in this case is 1/2 A plus B plus C. Doesn't really matter the order. So I'll just say 10 plus 14 plus 15. Add all those up, divide by 2. What do we get there? That's 14, 24. It'd be 39 for us. So half of 39, 19.5. All right. So it's just then taking that S, plugging it up here to each of these spots. So really, the only thing you got to worry about on this one is just be careful as you're plugging this stuff into your calculator when it comes down to it. Show some work like this, and you'll at least get yourself partial credit if you make some goof up. Show plugging those numbers in here. In other words, if you show this step here where you say, all right, this is going to be 19.5 times 19.5 minus A times 19.5 minus B times 19.5 minus C. And if you show this and then you totally goof up all your work in your calculator, well, you'll still get some partial credit for showing proper work. Okay. So anyhow, you should get a final answer on this one. What do we get? It's to the nearest tenth is 67.7. Now, if you just left the answer like that, you're going to lose a half point because we are given units here. So this is its area, so it's yards squared. So you got to make sure you show proper work in that respect. All right, and then the last one. So also finding the area. This is a little bit easier one here because we are given an angle here and two sides. So we have some formulas for figuring this out. So this is side C over here. This is angle B, and this is side A here. So if you are given an SAS situation, that means the angle is between the two sides. SAS, angle between two sides. We could actually use some area formulas that we got 1/2 BC times the sine of A. That's one possibility. Well, we're looking for something that uses sine of B here, though. So we use the area formula for this, which would be involving sine of B. Now, I'm going to let you have these ones too for this particular quiz, but pretty easy to remember these. Whatever the angle is that you're taking the sine of, you use the other two sides that are not that angle or not opposite that angle. So if I'm trying to find sine of B, that means I'm using little a, little c here. So I'm not going to use this, so I'm just going to use this. Plug in some numbers. 1/2 A, 7.7, C, 14, sine of B, which is 71 degrees. Work all that out. And of course, on all these, make sure you're in the proper mode. If you are in radians mode, you will have some issues. So make sure you are in degrees mode on your calculator. You work all that out, you get 51. 51 what? We're dealing with kilometers, so this is kilometers squared. Please do not forget units. Okay, super important. All right, that's it. Good luck.